Hello, math students. This lesson is called Fractions and Decimals. And in this lesson, we are going to talk about how you can add, subtract, multiply, and divide fractions and decimals to answer word problems. If that sounds like a lot, it is. We are going to review a lot of different things you can do with fractions and decimals to help you solve problems. If you had me for developmental math, you know already that we spent about 6 different lessons talking about all of this. So this video here is really just a review of all of those different lessons. If you did not have me for developmental math and this feels like a lot after you get through this video, please know that we have a lot of other resources. There's more videos I can share with you if you need, and also there's a lot of extra practice we have on these if you are not as familiar. We are going to start though with everyone's favorite, with fractions, and we are going to look through a couple different stories related to doing math with fractions. So our first one says Chance is walking to school, which is 7/10 of a kilometer away. He has already walked half of a kilometer. How much further does he have to go? So to summarize what the story is saying, he is walking to school, so maybe this is where he lives and he's trying to get to the school building. We are told that the school is 7/10 of a kilometer away. So that entire distance is 7/10, and he has already gone part of the way. If I put him right here, we are told that he has already traveled half a kilometer. We are trying to figure out how much he has left to walk. And in order to do that, we're going to use subtraction. We're going to take that entire distance he has to travel and subtract what he has already traveled to figure out that question mark there, to figure out what's left. Now, I know I want to subtract these two fractions, but in order to subtract these fractions, there's something I need to change. If you want to add or subtract fractions, you need the denominator to be the same. That's that bottom number. And right now, I've got a 10 and a 2. They are not the same. So before I can subtract, I need to make them the same by finding an equivalent fraction that has the same denominator. The way we do that is with multiplication. I look at the fraction that's got the smaller number, the 2, and I think about what could I multiply that by to make it the same as the denominator in 7/10. And I know that 2 times 5 gives me 10, so I'm going to multiply by 5. Not just the bottom number, not just the denominator, but also the numerator, the number on top. When I do that, 7/10 is not going to change. I keep that one the same. But now my 1/2 there is going to change to 5/10. I'm allowed to do that because 1/2 and 5/10, those are the exact same amount, but now the denominator is the same, which lets me subtract. When I go to subtract 7/10 minus 5/10, I do 7 minus 5, that gives me 2. And then my denominator, that 10, stays the same. So we get 7/10 minus 5/10 equals 2/10. Now, anytime you're working with fractions, we always check to see, can you simplify your fraction? And here, that fraction 2/10, I can simplify. I'm just going to copy it up here a little bit. In order to simplify that fraction, it's kind of like the opposite of what we did here with the multiplication. Simplifying a fraction means we're going to keep the amount the same, but we just want the numbers to be smaller. And we use division to help us do that. So I look at the 2 and the 10 and I ask myself, what is a number I can divide both of those by? And I know I can divide both 2 and 10 by 2. It has to be the same number. And when you do that, it gives you a fraction that equals the same amount, but has smaller numbers in it. 2/10 and 1/5 are the same amount, but 1/5 is simplified because it has smaller numbers. So to answer that question, how much further does he have to go? That question mark I've got right there is 1/5. I can say he needs to walk 1/5 of a kilometer more. That's what he has left to walk. This first example right here is all about what we need in order to add or subtract fractions. In order to add or subtract fractions, you need that bottom number to be the same, which is why I started with that multiplying 1 and 2 by 5. When you add or subtract fractions, you also always want to make sure that answer is simplified, and we use division to do that. I've got one more example here. It's this story here about Latanya. Latanya's new plant grows 1/8 of an inch each day. How much will it have grown by the end of the week? And we're talking about a week here. We're not talking about a work week. We're talking about a full week, so 7 days. So here we've got a plant that grows 1/8 of an inch, and that happens every day. So in one day, it grows this much. We are trying to figure out how much it grows by the end of the week, so how much it grows after 7 days. There's actually 2 different ways you can do this. You can take your 1/8 of an inch and say it grows 1/8 of an inch on Monday, and 1/8 of an inch on Tuesday, and 1/8 of an inch on Wednesday, and do that 7 times to get your answer by adding up how much it grows each of those days. Or, and the way I'm going to do it to save us some time, is using multiplication. I can say it grows 1/8 of an inch each day, and it does that for 7 days. When you go to multiply fractions, it's a little different than adding and subtracting fractions. When you multiply fractions, it is not necessary that the denominators are the same. So that's great news. I don't have to worry about changing 7 to a fraction with 8 on the bottom. That is not necessary. What is helpful when you multiply fractions is it actually helps to have both of the numbers be a fraction. So here, the first thing I want to do is I want to make 7 look like a fraction. And we do that by making it 7 over 1. If you ever have a number and you want it to be a fraction, you can make the denominator 1. I can do that because this just says 7 divided by 1, and 7 divided by 1 is 7. That's true for any number. 2 would be 2 over 1. 100 would be 100 over 1. That denominator is just 1. After you do that, then it's real easy for us to multiply. When you multiply 2 fractions, you just multiply going straight across. So 1 times 7 is 7, and 8 times 1 is 8. Just like last time, if you are multiplying with fractions, you always want to check and see, can you simplify? Here, I can't simplify. I know I can't simplify because there is no number you can divide 7 and 8 by other than the number 1. And we said you always have to divide by the same thing. So for example, I can't divide by 2 here and 7 here because it's not the same number. The only number that's the same that you can divide both of them by is the number 1. But if I do that, notice I'm not simplifying anything. I just get the same fraction. So we've got our final answer then. The final answer is 7/8. And so to answer that question, how much will it have grown by the end of the week? We can say the plant grew 7/8 of an inch by the end of the week, if you want to say that. These 2 examples here emphasize these points. First, we said if you are adding or subtracting fractions, the denominator, that bottom number, must be the same. And when you go to add and subtract your fractions, you only do math with the numerators, that top number. The denominator will stay the same in your answer. The second example we just did was multiplying fractions, and we saw when you multiply fractions, you multiply going straight across. And one of the nice things about multiplying fractions is the denominators don't need to be the same. So for example, if you had 1/2 times 2/4, we don't have to worry about making these the same. You can just multiply straight across and get your answer that way. Now that we've talked about adding, subtracting, and multiplying fractions, I've got one here for you to try. Go ahead, read through that story, pause this video, and try it on your own first. That'll be a great way for you to check in and see how you're doing, and then press play when you're ready to see the answer. Go ahead, stop the video now and try. Okay. This question here is very similar to the plant question we just looked at. There are two different ways you can do this. You can say she needs 2/3 of a cup of flour for each loaf of bread. And so if she makes 6 loaves, she needs 2/3 for the first one. She needs 2/3 for the second one, 2/3 for the third one, the fourth, the fifth, and the sixth. And let me make that 2/3. So this is one way you could do it. I think the easier way, though, is just saying she needs 2/3 of a cup of flour for each loaf of bread, and she is going to make 6 of those loaves and use multiplication. We just said a moment ago, when you're multiplying, it helps to have both of these as fractions, so I'm going to make that 6 over 1. And then when we go to multiply, 2 times 6 is 12. 3 times 1 is 3. I've got an answer. The final thing I need to do is check and see if it's simplified, and here it is not simplified. When you go to simplify this, you could, if you want, start by dividing both by 3. That gives you 4 over 1, but there is a way to simplify that more. It's the opposite of what we just did with the 6, right? You took that 6 and you made it 6 over 1. That means 4 over 1 is just the same thing as 4. We can say she needs 4 cups of flour. The other way you can get to that 4 is just by noticing that this problem right here is not actually a fraction. It just says 12 divided by 3, and 12 divided by 3 is 4. Both of those are ways that you can simplify and get to that 4. If you were to add up all of those fractions, the 2 plus 2 plus 2 plus 2 plus 2 plus 2 also gives you 12, and then you'd be keeping that denominator the same. And so you end up getting the exact same answer. These are all of the examples I have for this video on fractions, but remember, if you are not feeling confident with fractions, first of all, you are not alone. A lot of students don't start feeling confident with fractions. But we have a lot of practice we can send your way. I've got more videos and more examples I can send your way too. Just please reach out to me and ask, and I'm more than happy to help. The second half of this lesson is going to be all about decimals. And so just like the first part, I've got a lot of different stories for us to read through to help us practice doing math with decimals. For a lot more students, they feel a little more confident with decimals because one of the most common places you see decimals, and the way we're going to see it in the story, is with money. And as adults, we are usually much more familiar with money. For this first one that we're going to do, it's a story about Brenda and Jenna. Together saved $12.75 last week and $8 this week to buy a gift for Mother's Day. There's going to be a total of 3 questions related to them buying a present for Mother's Day. Part A says the gift they want to buy costs $17.50. Do the sisters have enough money for the gift? For us to decide if they have enough money, first I need to know how much money they have. And if I read through the story, it looks like maybe they have $12.75, but then I notice they also saved $8. And so I need to get that total money they saved. In order to find the total money saved, I'm going to need to do some addition. I'm going to add the $12.75 they saved last week plus the $8 they saved this week. Now, when you go to add the $8, we are not going to put the 8 over here. And the reason for that has to do with what each of these numbers represent. The 75 right there, that's 75 cents. And so if I put 8 below that, that would mean 8 cents, not $8. If I want to add $8, I need to put it below the dollars. So that means I need to put it below the 12. When it comes to adding and subtracting with decimals, it is important that you line up the whole numbers. So here that's the $12, the $8, and you line up the decimals. So here that would be the 75 cents. And for $8, $8 is just $8.00. Making sure that this decimal point right here lines up is essential when you add or subtract decimals. So now that I've got them lined up, I can go ahead and add this, and if I do, I get $20 $20.75. So if they have saved a total of $20.75, have they saved enough money for the gift? I could say yes. Yes, they have enough money. And it's always good to explain why. Yes, they have enough money because they have $20.75. So they could buy something with $17.50. That is the first part. It's all about when you add and subtract decimals, you want that decimal point, just like I have here, all lined up. You want it all to be in the same place, right there. The second question is asking if they want to split the cost of the gift, how much should each pay? So here they are splitting the cost of the gift. And so I might need to read through the information again. How much does the gift cost? Our gift cost, it tells me right here, $17.50. And so if they are splitting it, what does that mean? That means they are sharing the cost. They are dividing the cost. And what are they dividing the cost by? Well, up here, I see there are two of them. There are two sisters, so they're going to divide the cost by 2. I'm going to write down those words. They are taking the cost of the gift, and they are splitting it by the 2 sisters. So for this problem, I need to take my $17.50, and I am going to divide that by 2. In order to do that, I'm going to use some long division here. I'm going to give myself just a little bit more room, maybe. I need to take that $17.50, and I want to divide that by 2. So to do this division, I'm going to first ask myself how many 2's are in 17, because I know 2 does not fit in 1. There are 8 2's in 17, because that is 16, and that would mean there is 1 left over. I'm going to bring down my 5 here. I don't need a decimal point right here, but I do need to copy that decimal point up here. To get the next number, though, I'm just going to think how many 2's are in 15. Don't worry about writing 1.5. How many 2's are in 15? I know there are 7, because 7 times 2 is 14, and I still have a remainder. I have 1 left over, so I get to do this one more time. I've got how many 2's are in 10? I know there are 5, because 5 times 2 is 10, and now we are done because my remainder is 0. So if the sisters wanted to split the cost of the gift, how much should each pay? We can say each pays $8.75, like that. The final question related to this story is right here. We've got, just as a reminder, the gift that they want to buy costs $17.50. Oh no, this is the same problem. One moment. I found where it was. It was just down here. The final part of the story is Brenda also wants to buy 5 chocolate bars for their mom. Each chocolate bar costs 95 cents. How much total money does she need for the chocolate? So here she's buying 5 chocolate bars. So you can always picture 5 green chocolate bars. And we know each one of those costs 95 cents. It kind of makes me think of what we had talked about earlier with the fraction problems. Is you could do 95 cents plus 95 cents plus 95 cents and use addition to help you figure this out. Or the way I want to do it, I know each chocolate bar costs 95 cents and we're buying 5. So we can take that price and multiply it by 5. Now above, we had said that when you add or subtract decimals, you want those decimal points to line up. So if I was doing 95 cents plus 5, for example, that 5 would have to be right here. But when it comes to multiplication, it's not necessary to line up those decimal points. So for multiplication, I can just put my 5 right over here. And when you go to multiply, you multiply like you multiply any numbers. 5 times 5 gives me 25. 5 times 9 is 45, plus my 2 is 47. and then 5 times 0 is 0, plus my 4 is 4 there. The final part to this is where you would put your decimal point, and the way you figure it out is you count how many numbers come after the decimal point in the problem. So for example here, there is a total of 2 numbers after the decimal point, so I need 2 numbers after my decimal point in my answer, and so it would be 475. To give you another example, if you were multiplying 0.95 by 0.5, you would end up getting all the same numbers here, but this time we would have 1, 2, 3 total numbers after our decimal point. So I would need 3 numbers after my decimal point, and it would go right here. To decide where the decimal point goes, you're just counting how many numbers come after the point in the problem. But this was not for this problem. This one was. And so how much total money does she need for the chocolate? We could say she needs $4.75 for the chocolate. Again, the purpose of these 3 questions was to review how you do math with decimals. And so I'm going to go down to that summary here. To add or subtract decimals, the decimal points must always line up. And that is also where that decimal point goes in your answer. So for example, if you wanted to do 2.5 plus 3.11, that 2.5 and that 3.11, those decimal points need to line up. And then that is also where the decimal point would go in your answer. When you are multiplying decimals, it is not necessary to line up those decimal points. So for example, if I took those same 2 numbers, that 2.5, it's okay if it goes over there. But what is important when you're multiplying decimals is you have to count. So here, 1, 2, 3 numbers after my decimal point, and that's how many numbers should be after the decimal point in your answer. So that multiplication would take me a little longer, but I do know that there would be 3 numbers after the decimal point in my answer. And then finally, when it comes to dividing problems and writing your answer as a decimal, we're always using this long division that we did up here. That helps us know what the numbers are too, but also where that decimal point goes in your answer. So to practice adding, subtracting, multiplying, and dividing with decimals, I have a practice problem for you all. Just like we said above, please make sure you are trying this practice problem first on your own and then come back to the video and check and see how you do. This is just like we do in class, right? It's great to get practice first and then check in and see how you're doing on the topic. So this is your practice problem. Go ahead, stop the video now to try it and press play when you're ready to see the answer. For the first one, we know she biked 47.5 miles every day, and we are told she does that every day, Monday through Friday. So Monday, Tuesday, Wednesday, Thursday, Friday, each day, this is what she bikes. And so to figure out what that total distance she bikes, I'm going to take this and multiply it by those 5 days. When I do that multiplication, 5 times 5 is 25. 7 times 5 is 35, plus my 2 is 37. And then 4 times 5, 20, plus 3 is 23. To know where the decimal goes in my answer, I'm just going to count. I see 1 number after a decimal point in the problem, so that means I need 1 number after the decimal point in my answer. So we can say she biked 237.5 miles. That is a lot. For part B, we've got she biked 12 miles on Saturday and 9 miles on Sunday. So what is the total distance Becca biked this whole week? Well, we already know Monday through Friday is this 237.5 miles. So now I just need to add in Saturday is another 12 miles and Sunday is 9 miles. For me, I'm going to go ahead and just say, well, I know 12 plus 9 is 21. So I need to add in the Monday through Friday amount, 237.5, plus what she did on the weekend. And we learned if you're going to add 21, that has to go under the whole numbers. So that would go right here, and then I can just say 0.0. So our total for Becca for the entire week would be 258.5 miles. I'm tired just thinking about that. I've got one final one related to Becca and her biking across the country. For C, it says she has 300 miles she needs to bike on the last 8 days of her trip. On average, how many miles should she bike each day? One final time, stop the video here, try this problem, and come back to see how you did. For this problem here, we know this is the total she needs to bike in a total of 8 days. We are trying to just figure out how much she should do each day, or how much she should do in one day. So for this, I need to use division. I'm taking that total distance of 300 miles, and I want to divide it by how many days she has to do it. And then if I do that, it'll tell me how many miles she can bike each day, or in one day. To do that division, I'm going to use some long division. So 300 divided by 8. 8 does not go into 3, but 8 does go into 30. 8 would go into 30 3 times, because that's 8, 16, 24. That leaves me with a remainder of 6. So now I can bring down my 0 and go again. How many 8s are there in 60? Well, I think there are 7, because 7 times 8 is 56. That gives me a remainder of 4. I have no more numbers here to bring down, but I can use decimals. I can say, well, 300 miles is the same thing as 300.0 miles. And by putting that 0.0 there, that helps me, because now I have another number to use. I can say how many 8s are in 40, and there are going to be 5. I've put that decimal right there at the same place where I put the 0.0. 5 times 8 is 40. And that gives me a remainder of 0, so I know I'm done. So on average, how many miles should she bike each day? She should bike 37.5 miles per day. If she did that every day for 8 days, it would give us that total 300 miles she has left. Same thing we said above with the fractions. This is a summary of multiple lessons that we do back in the developmental math class on doing math with decimals. We spend, I think, 3 days in that class talking about how you add, subtract, multiply, and divide decimals, and how you can use them to help you solve stories like this. So if you feel like you need more examples, or if you want more practice on this, please reach out. I can send you more videos. I can send you more practice. I am super happy to do that. Hopefully you found this video helpful. It's a great summary of how you do math with all these different types of numbers. And hopefully you enjoyed this video and it helps you do the homework. Thanks so much for watching. Bye.